Alright, the median of a triangle is a segment whose endpoints are a vertex and the midpoint of the side opposite the vertex. The medians of a triangle always start at a vertex, and every triangle has 3 of them. So if I was going to draw the medians of this triangle, I would find my midpoint, start at my vertex, and voila. I'm going to make it red so it stands out. I'll make it a little more. So this is my median, which means that this portion is equal to this portion. Now, every triangle has 3 medians, so this is the median, and then here's another median. So notice I'm starting at my vertex and going to the midpoint of the opposite side. Now once I have my 3 medians together, they intersect, and their point of concurrency right here is called the centroid. We're going to talk a lot about this on Monday. But your centroid has some special qualities, and these qualities are, it comes from the vertex. It's the balance point of our triangle, but it comes from a vertex, goes to the midpoint of the opposite side, but it is split into proportions, and those proportions are 2 to 1. So that means for everything that this one value, this little portion equals, from the centroid to the midpoint, from the vertex to the centroid is going to be twice that. So this portion, let's say the little portion, is 1/3 of the whole, and from the vertex to the centroid is 2/3 of the whole. So, for example, if I want to call this A, B, and we'll call this C for centroid. So if I told you that AB equals 9, then you could tell me that AC is 2/3 of 9, which is 6. And you could tell me that CB is 1/3 of 9, or 9 divided by 3, which would be 3. If I were to tell you that AC was equal to, let's do 8, then you should be able to figure out that because my ratio AC to CB is 2 to 1, then CB must be equal to 4, which means my whole median is equal to 12. I like to think of it as, if you take your whole median and divide it by 3, the smaller portion is the median divided by 3, and then if you double that, you'll get your bigger portion. So let's look at example 1. In example 1, I've been given a median, and I want to find AB if BD is my median. So BD is my median, and I want to find AD. Oh, I want to find AB, I'm sorry. But in order to find AB, I have to know what X is. So I'm going to start by setting these equal to each other, because since BD is my median, then I know that these two things are equal. So 2x minus 17, if I solve for x, I should wind up getting x equals 20. And then once I figure out what x is, I can plug it in here, and 20 minus 7 gives me 13. All right. Altitudes of a triangle. So the altitude of a triangle is a segment from the vertex that is perpendicular to the opposite side or the line containing the opposite side. And an altitude can lie inside, outside, or on the triangle. When you first did area of the triangle and you were trying to find the height, you called it the altitude. So if I'm going to draw my altitude, I come from the vertex. I come from the vertex perpendicular to the opposite side. So this line is a perpendicular segment. All right. Now, every triangle is going to have 3 altitudes. So I need to be perpendicular to the opposite side. And like I said in our little small groups, you can use the corner of a piece of paper to make sure that you're perpendicular. And then let's draw this third altitude perpendicular to the opposite side. Okay? Now notice, this is our 4th triangle center. And all of our altitudes meet right here. So their point of concurrency is right here. And we call that point of concurrency the orthocenter. So that is our orthocenter. And because our altitudes can lie inside, outside, or on the triangle, that means that our orthocenter can also be located inside, outside, or on the triangle. So here's my perpendicular. And notice, in order to get this perpendicular, I had to extend my side of my triangle in order to find where it would be perpendicular to side AC. Now when I'm going to this vertex, from vertex A, I don't actually have to do that. It's just right there. And that one is my perpendicular right here. And then my third one, I want to make it perpendicular, but it looks like I'm going to have to extend my side out so I can draw my perpendicular line. And so there's my perpendicular line C. Now my orthocenter is where all 3 of these lines are going to meet. So let me make this dash so it's a little easier to see. If I make these blue, maybe there we go. All right, so these blue lines are all of my altitudes, and if I was to extend them and see where they meet, that would be my center. And notice how far outside the triangle it's going to be. It's going to be way out here. But way down here would be where my orthocenter was for this particular triangle. Now this one, my orthocenter is on the triangle. This is a right triangle, so this is one of my altitudes. That counts as one of your altitudes. And then, well, in this case, it counts as two of my altitudes, because BC is perpendicular to AC, and CA is perpendicular to BA. So I really only have to draw in one more. And so in this case, this is my perpendicular from vertex A, but all three altitudes converge right here. So this is their point of concurrency. That is my orthocenter. And it's on the triangle. So inside, outside, on the triangle. And don't forget that your altitudes are always going to start from a vertex. All right, let's do another example with altitudes this time. And then I have some mid-segment problems for you to practice. So the question is, find BC if AD is an altitude of triangle ABC. So if this is an altitude, then I know that 4x, that this must be perpendicular. So 4x plus 10 must equal 90 degrees. So that's how I can solve for x. That's how I would set it up. 4x plus 10 equals 90 degrees. So x equals 20. And then we want to find BC, which is this entire length. So we just need to plug in 20 here. So 60 minus 4 gives me 56. And 2 times 20 gives me 40. So BC, because of second addition, BC is going to be BD plus DC, which is going to be 96. All right, I put some median problems on the back of this for you to practice. So pause the video and then come back to get the answers. All right, in the first question, you were trying to find Fn if Mn equals 12. So these are just side lengths. And remember that your median, goes to the midpoint. So F must be the midpoint. And in this one, we want to find Xi if Fi equals 16.8. So this is using that 1/3 to 2/3 ratio. Fx is 2/3 of the entire length of the median, and Xi is 1/3 of the median. So if I know that my whole median is 16.8, I can just say 16.8 divided by 3, and that should get you 5.6. All right, the rest of the answers. And those are all going to be kind of solved similarly. So median going to the midpoint, x is 2. Then this is using the properties of a median, the 2-to-1 ratio. And x is 3. All right. 5 and 6, using the 2-to-1 ratio. X is 2, x is 4. All right, number 7, we want to find VD given DC and VC. So just remember, using the fact that V is going to be the midpoint of DC. Here, using the 2-to-1 ratio. 2-to-1 ratio. 2-to-1 ratio. All right, make make sure you ask me any questions, and we're going to practice all the triangle centers on Monday.